Hey guys, and welcome to this new section in this course in aircraft systems and avionics. Today we will start by introducing and studying the basics of the electrical system. Right, so the definition of the electrical system is a self-contained network of components that generate, transmit, distribute, utilize and store electrical energy in an aircraft. Now, electrical design in aircraft is influenced always by two basic requirements. The equipment must be lightweight and also highly reliable. These needs may be met in a variety of ways. Now, lightweight equipment and highly reliable equipment is actually a thing which is related to any system in an aircraft. It is essential to make sure that all systems are lightweight and highly reliable. Okay? Now, an airplane contains two major electrical circuits, which are usually named simply number 1 and number 2. Okay? And also an alternate circuit, which may depending on the aircraft, or may depend on the type of aircraft, for instance. Now, the two circuits, one of each side of the aircraft, are linked to a generator. It is this generator that will produce the electricity using the mechanical energy supplied by one of the engines. Okay, so each of the generators, generator number 1 and 2, are related and are based on the mechanical energy that we obtain from the turbines, from the aircraft engines. Right? The electrical circuits used are based on different components. First of all, we have generators, as we mentioned before. Then we have the alternating current buses, which is the transmission of the current through alternating current. Then we have this area which is based on transformers, which we will explain in a bit. And finally, this area over here, which is the most utilized in aircraft, which is based on DC current. Okay. Right, so as previously mentioned, electrical parameters are chosen to minimize the weight so the aircraft can get off the ground with its payload and gain altitude without expending unnecessarily power and fuel, right? So one technique is to reduce the size and the weight of magnetics, which imply generator, transformers and motors, by employing basically a higher frequency power system. Ground-based utility power, as you probably know, is generally 50 or 60 Hz. However, in aircraft electrical systems that are AC, they will typically operate at 400 Hz, since the magnetic core, hence transformers for instance, can be made much smaller with the same power level. Even small private single-engine airplanes have complex electrical systems. They are usually based on two magnetos for redundancy, and many other components, which we'll be discussing now. Now, an example of an aircraft electrical system would include two batteries, two engine-driven variable frequency AC generators. Okay. Then we have a constant frequency 400 Hz AC generator and a ram air-driven constant frequency generator for emergency use. So basically we have one generator per each engine, this which is called the APU generator, and the emergency generator. Okay. Now, DC power comes from two 28 volt transformers rectifiers. Okay, these are used in order to transform the AC current to the DC current, right? So aircraft typically have 14 to 28 volt DC systems, providing the charging voltage for the batteries for 12 and 24 volt. Wet cells or sealed lead acid batteries. Okay, this may depend on the type of aircraft. Right, so we can go to the next class.